I just wanted to make sure that I explained very clearly the difference between how to figure out whether a molecule is polar or nonpolar. So we'll first start with the example of ammonium. Ammonium is an example of a nonpolar molecule. You might want to say, well, how do I do the steps that get me there? All right, well, first you have to look at the formula. So NH4 positive. NH4 positive indicates that it has all valence electrons minus 1. So 5 from the nitrogen, 1 from each hydrogen, and then finally the positive ion indicates that you need to take one of these 9 valence electrons away. So we have to draw our model with the nitrogen in the center, hydrogen's on the outside, and you notice that these 4 single bonds, since each bond represents 2 electrons, adds up to the 8 electrons that we should have in this model. So there you have the two-dimensional dot structure for ammonium. The second step is to actually visualize the shape. So you have to imagine that these 4 hydrogen atoms are not really making a plus sign with the nitrogen, that this is really in a 3-dimensional space. In a 3-dimensional space, these 4 hydrogen atoms would separate as far from each other as possible, what I call the tripod with a camera arrangement. So you can visualize the tripod with the camera, and when you do this, you realize, hey, these electrons are actually pulling towards the nitrogen, and what that looks like in terms of an overall picture would be that you have no net electron pull to one side of the molecule. So if you look over here in the lower right-hand corner, you've got the nonpolar molecule, and that visual for it is to say, hey, wait a minute, all of my positives aren't pulling towards one end of the molecule. In fact, the entire outer surface of the molecule is more positive than the center. Next, let's look at sulfur difluoride. With sulfur difluoride, we have a model with 20 valence electrons. Notice how every shell is filled with a total of 8 electrons around it, every atom's outer shell. And when we do that, we get a bent shape. We get a bent shape because the lone pair electrons on the sulfur actually create a lot of repulsion for each other, as well as for the electrons that would be on the fluorine. So these 2 lone pair electrons actually push the fluorine atoms closer together, creating this bent shape right here. So after you calculate the shape, what you can do is look at the individual bond vectors and see that fluorine, being of the highest electronegativity, will pull a lot of the electrons closer to the ends. What this looks like in a 3-dimensional shape is that in the molecule, the fluorine end is going to be more negative, and the sulfur end, that would be up here, is more positive. This looks like a magnet, and this is what is defined as a polar molecule. That's it for determining whether something is polar or nonpolar. Tune in for the next episode.